This slide was prompted actually by the oil industry talk, because this, I think, demonstrates that the human race is completely doomed. This is a Dyalog bag here, in fact, this one. And that is a lake in Chile, in the Atacama Desert. And what you're looking at there is 15% of the known reserves of the world's lithium. And it's not a terribly big lake. You can see most of it. So I don't think these guys are going to be out of business to electric cars just yet. The rest of us may have a problem when in fact... Well, the Scots, of course, have got a big problem because they have run out of oil. We English have nicked all of it. So I just thought you'd be interested to see that. All right, we can get rid of that one. A couple of small things before I hit the Nestle trail, or the Rowntree trail. Something that I thought I ought to show you, which I've been using for years and may have got forgotten about. It is extremely easy to make your own APL keyboards with this thing. Now, I use the Alt-Gr stuff, and you'll notice if you look over there that, in fact, I've upgraded this in the last couple of weeks because I now have Key on Alt-Gr K. Thank you, Roger. Key is absolutely brilliant. And IOTA is about to gain IOTA underbar because I'm going to be ahead of him on that one. I want it on my keyboard before I get it in APL. So this thing is a free download from Microsoft, and it is utterly simple to build custom keyboards. So I just hack around with this thing until it's comfortable. So I would actually recommend that basically all you do is go into regional, install it, and it's just there in regional settings as a keyboard. And I use mine all the time. So with that in mind, let's just go through a little bit of background. Okay, who am I? I did physics at university. I spent 20 years at Rowntree, basically in the operations research area, and which started off very much as a physical job, looking at process control, looking at bits of the factory. It was definitely a case of hiking around. I did the 3-day confectionery course. I can actually make some of the stuff. But a lot of that then began to evolve very much into a computing role. So I come at this whole process really from looking at industrial processes and seeing where APL was beginning to fit into this environment. So I thought it would be interesting to go through, lost it, here it is, some of the reasons why chocolate is actually quite difficult. And this is almost exactly the opposite of what you saw from the oil talk. What oil is a complicated thing, and you're trying to simplify it down to stuff that you understand. Whereas what you're trying to do with these is start with a bunch of stuff that is really simple and put it together in ways which is relatively complicated. So if we, you're very welcome to take these home with you. I haven't brought enough for everybody, unfortunately, so I just have to dish them out. But if we look at one of these things, you think, oh well, that's fairly simple. You can see it's got some chocolate on the outside. If we snap it in half, you can of course eat it, which is quite a good thing. You notice you've got a series of layers in there, which is a wafer and a layer of brown gunk, which is used to stick the layers of wafer together. So far, so good. The brown gunk is actually ground up Kit Kats. Yeah, about 10% of these fall on the floor. The wrapping machines destroy them. Yeah, they go wrong. You can see if you look at the back of them, there's quite a thin layer of chocolate over the wafer. Any that it doesn't cover, you basically have to reject because it will rapidly absorb moisture and go sort of. You
said 10% of what?
10% of the finished product.
Yes, that's a Kit Kat.
That's a Kit Kat bar.
And it's made with
10% of a Kit Kat bar. 10% of the brown gunk sticking those biscuits together is Kit Kat bars. Yeah. Now, when Rowntree then Nestle first went, SAP the large German outfit that's taken over the software world, were desperately trying to get into the food industry. And when we told them this, because they had a wonderful bill of materials system that was great at making, BMWs and bicycles and, Mercedes and things built in Germany out of nuts and bolts. And their system actually just rejected the recursion immediately. It just couldn't. Yeah, a bill of materials through a tree where elements of the tree were looping were, involved back at the top. And so we went through most of the products that the Rowntree people made, and virtually everything. The reason you can buy ginger nuts, every biscuit company makes ginger nuts, because ginger nuts are all the crap that they've swept off the floor, ground up, and if you put enough ginger in it, nobody can tell. No, it's a very, very good product. It's almost free from an ingredient point of view, because it is all the stuff that you'd otherwise have to feed to the pigs. There are some very glossy pigs near to many food factories, of course. Actually, the best example of that was the yogurt factory near Bradford-on-Avon, which was actually on an old mill over a river. And the trout downstream of the factory were, serious fish. Anyway, so this is all about mixing stuff together. So one of the things I want to show you, of the little algorithms that did actually make a difference to the company, is how we resolve. It's pretty obvious how you handle the easy case, because you basically go through, you say the last step is obviously covering the wafer deck in chocolate. That's easy. The step before that is assembling the deck of wafers with the brown gunk. The step before that is making the brown gunk out of the, 10% of that. And the idiot mode approach to this then just iterates until it converges. Which you can, but the trouble is we wanted the composition to at least eight decimal places, because you were using this to do materials ordering, and it kind of mattered if you got an extra truck of sugar that you didn't need. So we're talking 600 tons a day of this stuff going through roughly going through the factory. So it's quite big stuff. Now, who knows the formula for the sum of a geometric progression? Anybody not know the formula? What is a half plus a quarter plus an eighth plus a, So all you do when you hit the simple case is go, yes, 1 over 1 minus r, done it. Replace this with everything that you got to date times whatever the sum of a tenth plus a hundredth plus a thousandth is. Right, done, bang, close form code straight off. Easy stuff. The problems come when you have effectively this going on, because you can very easily have this rework process. The wafers have probably also got a rework process lower down in the tree. You can cheerfully, with something like this, you'll have 4 or 5 cycles of material, and they're not necessarily separate. Obviously, if they're separated, so you just have a little bit of recursion in a subtree, piece of cake. If you've got interlocks in these things, anything which is trying to solve it by iteration will just not terminate. Anything which is trying to be clever with the tree in that state, you cannot actually evaluate that neatly. What you have to do is do some interesting cut and paste on the tree to effectively rearrange the recipe such that you can. You basically copy whole chunks of the tree down until you've got a simple tree, and you can then evaluate. So I'll show you a little bit of that stuff in action, hopefully. We've done the who am I. 20 years in chocolates, overlapped with the 20, don't add the 20s, obviously there's a kind of blurred edge to that, because probably the last 10 years of the chocolate stuff was writing APL. And I gradually evolved to being a computer person rather than someone who walked around the factory all day. I've been doing about 10 years as part-time greenkeeper on the local golf course, and I would say the last 5 I have made great use of computers as tools, but I've written almost no code. So I really have had about 5 years as a thorough career break out of this business. I could put the font size up a little bit. How about that? Yeah, I have that on a function key for obvious reasons. So I will just go for that one. So there may be quite a bit of stuff we can learn from the past. And what I'm trying to begin to understand is why APL fitted so well into the ecology at Rowntree's. Because there was a load of stuff that we were doing with APL right across the company. And when Nestle bought Rowntree, why it disappeared from the organization really rather quickly. And there are clearly companies in which APL is still, fits into the ecology of the company really well. It's worth, I think, trying to understand where those companies are and where the ones are that you really haven't got a chance of getting APL into, because it's just not going to... It was driven out very, very effectively and quickly from a company where it was quite well established. So it would be good to know why it worked so well in the early days, and what was it about Rowntree that made it work, and about Nestle that killed it, I think is an interesting theme. Right, let's just have a look at some stuff. Incidentally, this is well out of copyright, I'm sure. So, if this is now, I'm going to have to move you, aren't I? Because you're off screen. Give me a yell when I've got it somewhere near. Yeah. Interestingly, this text field up here picks up my session font, so it's gone big as well, which is actually quite handy. That is a complete accident. So here's the recipe of fruit pastels, for example. So if we just make you a little bit bigger. So fruit pastilles are these sort of things that you get in a tube that you suck for a few minutes, dusted with sugar. Yeah, they're very good for your throat. So the recipe is basically a series of stages. So the recipe for a pastille is a rubbed pastille, some syrup, and some water loss. So you can actually have a recipe stage when stuff just evaporates. Yeah, this is actually quite common. And then you've got the recipe for the syrup, and the flavouring, and sugar syrup, and oh look, something has rubbed pastille in it. That's interesting, isn't it? So the sugar syrup has actually got some of the things thrown back in the system, and so on. So we can just let's just watch this run through. So there's a tree, and as you can see, this one, it's already got it. Yeah, I think it just had one recursion, so it very quickly copied the tree through, resolved it down. You can see it's water, sugar, gum, starch. So that's your list of raw materials down to basically what you have to buy in order to make this stuff. So if we go for a slightly more interesting one, breakaway is a biscuit. So breakaways, baked biscuit and chocolate. Biscuit is dough pieces and water loss. Dough pieces is dough. Dough is biscuit crumb. So again, we've got a little bit of rework going on in there. And then biscuit crumb is baked biscuit. Ah, there we go. Yeah. So again, you've just got a nice simple one. So I can probably, if I hit step, I think. How about that? So we can just single step this through. Enter key would be quicker, wouldn't it? And you can see the tree, again, resolves straight back to a simple tree instantly. Right, forget that. So if we get a Kit Kat one, this is quite a wide beast, as you can see. There's quite a lot of that tree. And there is a lot going on in here. I won't try and go through this in detail, but what we can do is, again, if we watch it go through, is probably the best way, and you can just watch the tree flapping about. You'll see we've got a huge copy of a so we've duplicated great big chunks of the tree as subtrees. And it's now nipping around, and it's almost done it. It's now almost flattened it. There it goes. And we're out. So the difference, this is just one of these areas where having essentially a clever algorithm beats having a stupid algorithm by, not just factors of 100, but by actually making it possible to do this. There just isn't any way that you can actually produce, you could actually get a composition on this. This was worth about, just for KitKat, this was worth about 2 million quid a year, I think. The problem being that the way the customs and excise, we're in this European Union thing, for the moment, which means that we had to buy, a company like Rowntree is buying sugar at intervention price. So we buy sugar at the same price as you buy in Sainsbury's. But so as not to penalise manufacturers, at the end of the year, you can go to the customs and excise people and say, excuse us, please can we have back the difference between the stupid price that you charged us and the real street price of sugar in the UK. So there's a huge restitution process goes on that companies can reclaim back. And the weird thing is that you don't get charged on the amount of sugar that you brought into the factory. That's far too simple. What they do is they look at the amount of finished product, all of it, everything we make that use sugar, you add all that up, and then they say, okay, how much sugar did that use? So you have to convince, the reason we wrote this demonstrator was so we could give this to the customs and excise people, and they could sit here and press that button until they actually understood. Because Rowntree, and subsequently Nestle, were using this effectively to make the reclaim for all the intervention price sugars that they'd use, and it was a serious amount of money. So we needed something that was not only worked, but could be proved to work on a series of test cases that they brought us and that we made it work through. So one of the things that occurred to me in background reading recently, Marxism, one of the key elements of Marxism is the labor theory of value. So the value of anything is essentially the sum of the labor cost that went into making this thing, growing the wheat to make this thing, harvesting the wheat, building the combine harvester that harvested the wheat, digging out the steel, digging out the iron that made the steel that made the combine harvester that harvested the wheat that went in. So nobody and nobody has ever managed to work one of these things out. That Marx proposed that this was the way it should be done, and theoretically it's brilliantly sensible. But you might actually be able to use this stuff, at least to give it a try. Because again, it's full of loops. The reason nobody could work it out is it's not a tree. All over the place, you've got cycles in that process. So it would be quite. So this is. I still can't give you the KitKat recipe, but if anybody could see a use for this workspace, you're absolutely welcome to it. There's a GUI front end on this just for fun. The function is called the works. So all you need to do is understand how this works. Now the interesting thing about of course I made the font bigger. I made the font bigger, didn't I? Silly me. Foolish. Notice that this thing is entirely non-control structured. It is just all these functions which basically are remove recursive. These are the steps that you were watching the thing go through. There's a little function called wait there, which is doing some slightly silly stuff with quad DLs and whatever. But basically, this is the algorithm. Duncan and I spent 3 days in Waldorf taking SAP through exactly this. So they may well have implemented it. this program went out of commission at Nestle about 3 years ago. So I have some confidence that maybe this has outlived APL, which would be, I mean, it's perfect, you know, you implement this in anything. It's just extremely clever, and do not amend this function in any way, and for God's sake, don't try and redo it with control structures. You will probably die. Anyway, so that's all. That is it. All the rest of the crap in the workspace is just GUI, really. Which, 10 minutes left, brings me to one of the things. I'll just run very briefly through some of the other places where we used APL. If you want to read up on this in more detail, Stanford 81. Stanford 91, sorry. Proceedings are on the table out there. And I've got a paper in that, which is basically a summary of APL at Rowntree in 91. We used it for scheduling the truck fleet. That was immensely successful. Worked really well and was a big time saving. Warehouse loading. We built an enormous automated warehouse in Leicester, central warehouse, 12 high, lights out, you know, robot stacking, all this stuff. Trouble is they built it on a marsh. And what happened was, if you put this was after the Nestle hookup, if you put all the Branston pickle at that end and all the Easter eggs at this end, the whole warehouse did that. And then the cranes couldn't run. If it tilted more than half a degree, the cranes just all ended up at the bottom. It's very embarrassing. So we had a wonderful little APL Plus PC program which ran lights out for years called Blockbuster. And all it did was, obviously you could get the loading on each stack very easily. You knew what was in the pallet, you knew the weight of the pallet, you knew where it was. So all it did was draw a bitmap showing the weight as a color code. So it was a very, very early piece of really nice heat map graphics. And it literally just sat there in the warehouse manager's office doing exactly nothing except displaying this one bitmap updated about every 20 minutes. And yeah, I think that saved so much hassle, that program. And lovely bit of APL Plus PC, just ran. Scheduling all over the place. I did Blackmagic assortment was the first one I did, which was quite an interest. It was almost a GA before I knew what GAs were. Longer term planning. Personal computing. We were on VSPC mainframe for a long time. I had about 120 users on something I called Tabman, which was basically, I took one look at ADRS and thought it was terrible, and wrote something vaguely similar. It went to PGF for its graphics, so it used AP126 to use the IBM presentation graphics stuff, which I thought at the time was superb, and I still think it's actually a pretty good graphics engine. So that was all over the factory. We had factory managers, shop floor guys, team leaders, using VSPC terminals to do basic process control, data entry, how many tons of waste did we have today, let's have a meeting about it. All the stuff that people want to do in a factory day to day. VSPC mainframe. Plant information system, something astonishingly like Steve's lovely picture of a refinery where you clicked on the things and you saw how much was in that tank and all that crap. That was in Plus PC. So we went VSPC, Plus PC, plus 2, and I think that's about where we peaked. Windows, I'm never quite sure if that was one of the things that began the decline, because, and as with the slide that Steve showed us, a ridiculous amount of your code is interface code. And I think it slowed us down hugely. I think we were able to crank out stuff at the DOS level a lot faster than we were able to we couldn't keep up with the demands of the interface. Even with the Causeway tools that Duncan and I wrote, it still slowed you up getting the visuals to work. The reason I think primarily that Nestle killed it is they had a totally different attitude. Rowntree was all about making products as well as they could and then trying to do that economically. So they were absolute sticklers for, you mustn't muck with the recipe. This works. We need to get this flour from this supplier because that makes the right wafer. We need to stir the dark chocolate for 3 days because that gives you the right flavor and whatever. Which means you had a whole lot of very complicated interleavings of processes that were actually quite hard to manage. All Nestle do with this thing is go, that's hard to manage, we'll just make it cheaper. Which actually means that these are fairly nasty. And humanity is, there's a lovely short story about A.M. Foster called The Machine Stops. And one of the things fairly early in that is humanity had long got used to second best. That we're gradually becoming accustomed to poor, and black magic assortment these days is awful. It's just moulded truffles with a bit of chocolate slapped on. It used to be really interesting. So finally, I just turned this one up on the internet because it is related to, I might have to move this. This is a quote quad that Karen very kindly commented for me. Ping, makers of golf clubs. I got interested in this because someone, rather foolishly, had left one of these things. It was, I suspect, one of the kids at college. His dad had given him it. And he just left it behind. So we found it out in the course one day. I put a new grip on it, sold it to one of my colleagues for a tenner. But these guys were doing something remarkably similar. This is what putters used to be like. Now you'll notice with this thing, it's a uniform width there. And if you hit the ball right in the middle, it doesn't twist. If you hit it ever so slightly off center, look how much you're moving that. So this thing's got very low moment of inertia about that axis. What Carsten worked out, he's an engineer, which helps, he's also Norwegian, is if you put the weight at the ends, then if you hit it slightly off center, it's got massively higher moment of inertia. So this thing is so much more forgiving to an off-center hit. The other thing about this is it's brass, which means you can just forge it. But it's also soft as hell, which means if you hit it with things, it gets, you get notches in it. And again, if you hit it slightly with a notched piece, it won't go where you want. This guy's phosphor bronze. And these are, you have to cast them with, do you remember how the Romans cast bronzes? It's called lost wax. They cast them with a process called investment casting, which is basically a lost wax casting process. And so this is straight out of the casting process with no post-processing. It's an incredibly good precision casting. There is a whole website. If you can read the zip codes off them, it'll tell you which Ping factory Carsten was working out of. He moved factory 4 times as they built the business. Started in, ended up in Phoenix. Started quite close. If you find one of the very originals, then just put it on eBay. You'll get a lot of money for it. That one isn't. That one is about mid-1980s. So, again, they used APL absolutely forever. Just read that quote quad. APL was pervasive in that organization. They actually ran their numerically controlled machine tools to cut the molds out for that thing with APL. So I have 0 minutes left. I'm going to show you that. That's what they're making now. That is a piece of cheap tack. It's poorly molded. There's no detailing on it. It's the wrong material. The other great thing about this material is it has the same Young's modulus as a golf ball. So it shares the impact perfectly. You don't get any energy loss on the impact. That thing, it won't go ping for a start because it's the wrong stuff. And it has a label on it saying made in China. And it'll cost you 109 quid, for goodness sake. So, same thing. Any of the pros who are unsponsored, and if you go and follow the seniors tour, they're all using these old ones. They're way better than anybody makes now, for the same reason as these things are rubbish, and if you happen to find a 30-year-old one, it will taste actually still quite good. Anyway. Anybody prepared to catch who would like one? Thank you very much.